Hi, so this is an analysis of the red and blue problem from the educational Codeforces round 101. So here's the problem. Monocarbon has a sequence A consisting of n plus m integers, and then there are either two colors, red and blue, and then the n elements are painted red and the m elements are painted blue. So he has written down the two sequences R, sequence of R values, and sequence of B values. So the R ones are the blue elements, and the B ones are R ones are the red elements, and B ones are the blue elements. And he's trying to maximize this function, f of A. So essentially, with this subset, what this function is, it's maximum subset of an increasing length that starts from 0. So it starts at 0, first term plus second term, first term plus second plus third, first plus second plus third plus fourth, and so on. And he's essentially trying to maximize that function. But there's one condition, that the elements have to appear in the order that they came from. So if we take this test input, for example, for us to access the number 7, we have to have gotten number -5 first. And so yeah, that's a major difference. So I'll get the test again. So -5, 7, and 3. That's one. And this one is 2. Okay, so let's just go through it. Straightforward, right? So the first thing is 0. As you know, that's will always be 0. Now, second will just be the first term, so it would have to be one of this one or one of this one. So from first glance, it would appear, yeah, just take the 6. So let's just do it. 6, comma. Okay, so now this one's gone. So it's either one of this one or this one. So straightforward, just going straight into probably, you think that you take number 2. Right, so 6 plus 2. I'll just write 8. Afterwards, this or this, you take 3, so 11. And this or this, just so straightforward, you take number -4, so that would be 7. And then -5, so 2, 7, 9, or you get 11. Right, so if you just went straightforward into the problem, that's what you think the answer should be. But what you essentially have to do in this question is look further ahead, right? So let's do this problem again. So we start off with 0. 6 is a fine starting point. It's okay. Okay. Oh, this is -3. Okay. And this would be 6. So yeah, 0, 6. 2 is still a fine choice to take. So that'll get you to 8. And then 3 is okay, so 11. But now, we're stuck at this final point, between -4 and -5. So just looking at these two values, it seems like it would be much better to take -4. But you know, right after the -5 is a 7. So if you take this in one turn, and this in the next turn, the net value would increase by 2. Right, so it's optimal to take this one, and then this one right after. So judging that, you get 6, 13, 10, 6. And now, obviously you can see the max of this method is a lot larger than the max of the previous one. So what you can take from this is that instead of just looking at the first element, you have to look further into the right. to see if there is a maximum value of f of a within this list as well. So how do you translate that into code? So what you could say is define a function and then just call it like something random like max f that takes in the list. So yeah, R, and then once it takes in R, it finds the maximum set in this fashion from this entire list. So if this was R and this was B, I don't know, it would find the max would be this one plus this plus this. So I would. So if you take max f R, the output would be 8. So you can see that excluding this value right here, like just not only looking at this, but looking into the future, you can see that there is a net increase of values. So here's another depiction of a scenario like this. So we want a list 9, 7, 6, 4, and another list negative 20, 100, 100, 100. Negative 1000. So just by looking at the first value, you would essentially miss this value right here. Oh, I'm sorry. This is negative 18 and negative 17. Yeah, so you would miss the 100 palette behind the negative 20. So all of these values are larger than negative 20. So just by taking that approach, you would just pick up these numbers and skip this list entirely. However, just having that short-sighted approach, you would miss 100. So what could you do? First, loop through all the possible spots in the original array, right? So in this one, R is equal to 7, 4. So this 4 is like term 3. B is 3. So the original list has 7. So loop through that list. And then what you could do, right, is use this max f function. And then if max f R is larger than max f B, then take the first R term. And else take the first B term. And continue doing that, right? So essentially, yeah, that will help you get the highest value of this function that they're looking for in the problem statement. And then, yeah, so what's the code approach of this look like? So my code is horrible at this. But yeah, I just don't see that though. You have one function, or probably just use this one. You have one function that finds the highest subset of the list, or list. And then you continually test that. So function B of R, then take the first B, I'll take the first R, and then vice versa. One thing you also have to check for is if the size of the array is not equal to 0. So, going back to the first picture, let's just say this subset was the best that we could do, right? So we took this one as the first step, this was the second step, and this one in the third step. So now this array has no terms left, but this one has 4 terms. So if we continue using this approach, we'd essentially get an error because there's no way you can calculate the highest subset of a list with no terms. So yeah, essentially, yeah, that's what you have to do, and that will get you answer to the problem.